Okay, so now we are doing elimination reactions. Elimination reactions are the opposite of addition reactions. So in an addition reaction, you are making a double bond, a single bond, or a triple bond, a double bond, something more saturated. In an elimination reaction, you're doing the opposite. So you're making something more unsaturated. So again, when we are doing this for an alcohol, okay, we use a strong acid catalyst. If you see strong acid catalyst, you're like, right now, if you see strong acid catalyst and one chemical, boom, elimination. There's nothing this can react with, okay? So let's take a look. Butane 2-ol, if I draw that out, 1, 2, 3, 4. 2-ol means I got an OH on the second carbon, and then I will just draw out the rest of this. Okay, that's butane 2-ol. And now I have to think about what's going to happen when the strong acid catalyst gets put in a solution. So again, elimination means we are eliminating something, okay? And we're producing a double or triple bond. Now, again, if I'm eliminating something with only single bonds, I'm making a double bond. The question is, what am I going to eliminate? So whenever you see something unique in this chemical, you're probably going to eliminate it. So in this case, that is the O and the H. This is unique. So you are going to be eliminating this. Here's the thing. If I'm going to make a double bond, I can't just remove this. I also have to remove something else. I have to remove another hydrogen. So, and the hydrogen has to be beside that OH group. So I could eliminate this hydrogen to make a double bond there, or I could eliminate this hydrogen to make a double bond there. Let's say you eliminate this group right here. What's that product going to look like? Well, this is going to form water, and I'm going to have 1, 2, 3, 4. Again, just fill in everything else as per usual. Okay. I've eliminated the two groups that were there. So now I need to make a double bond here, and the product is going to be water. Okay. So again, if I eliminate a group from the second and the third carbon, I have a double bond between the second and the third carbon. Okay. This would be called but 2-ene. Okay. Well, I could, like I said, I also could eliminate the OH and the first hydrogen. So what's going to happen if I do that? So again, I could have this chemical and 1, 2, 3, 4. Draw everything else normally. Keep the base the same. Well, if I eliminate that the hydrogen from the first carbon, so if I get rid of those two things, I'm going to have a double bond between the first and second carbon. This chemical will be but-1-ene or butene. And again, water is going to be a product as well. So water is going to be a product from both of these. So I only need to write it once really. But these two chemicals can both be produced. So I'm not going to write this or that. I'm going to write it could be a combination of both. But again, what you guys need to see is whatever that signature functional group is, or that signature chemical, that group, if that's going to be removed, either this hydrogen has to be removed beside it or this hydrogen. Could it be the ones down here? Sure. But it cannot be any of the hydrogens over here because they are 2 carbons away.